Hello. This movie is for Unit 6, Learning Target 3, on systems of equations solving by substitution. So it's another method that we use to solve a system. As a reminder, systems of linear equations are when we have two or more linear equations together. We have the same number of equations that we do variables. Ways to solve, we looked at graphing already. We're going to use substitution, and then another way is elimination. Substitution only works for when the equations are in a certain form. So that's what we're going to look at today. Solving a system of equations by substitution. Here's our example. We've got two equations with two variables. What we're going to do is exactly what this indicates. We are going to substitute for one of the variables. You see how in the first equation I have one of the two variables equal to everything else. Y is equal to the 3x minus 10. What we're going to do is substitute that y in this second equation with 3x minus 10. So I get 3x minus 10 substituted in for that y is going to be equal to the 2x minus 5. We are essentially taking this and substituting it in for y in the other equation. That's what gives us substitution. Now here is the nice thing about that. We end up with one equation, one variable. So now I can solve this equation by getting the x's on the same side and then solve for x. And I get x is 5. Now the tricky thing is when you're solving a system of equations, you need to solve for both variables. I know what x is now, and now I need to solve for y. And to take x and plug it in, you can plug it into either of the two originals, and you should be able to get what y is. So we plug it in, and if I plug it in the first one, I get y equals 3 times 5 minus 10. So y is equal to 15 minus 10, y is also equal to 5. I get that x is equal to 5 and y is equal to 5. Now you can test that out in the second equation as well. But one last thing prior to going on to the next problem is that you should check yourself. This is going to happen mentally. I'm taking both of my original equations and I'm plugging in what y was equal to and I'm plugging in what x was equal to. So I get 5 is equal to 15 minus 10, 5. True statement. Take the second equation, y equals 2x minus 5. Plug in the y, plug in the x. And I get 5 equals 10 minus 5. 5 equals 5. It works for the second. When you get your answer for x and y, it should work to give you true statements in both of your equations. So always make sure that you are plugging it back in to double check your answers. Let's try another system. Why don't you pause the movie, try this one on your own, and press play when you are finished. Okay. In this example, we've got y is equal to x plus 4. So I'm going to take that x plus 4 and plug it in for y in the second equation. So I get x plus 4 is equal to 3x. I just took the y in this equation and substituted what the y was equal to from the other equation. So I have x plus 4 equals 3x. I'm going to subtract x. I get 4 equals 2x, and so therefore 2 is equal to x. Now that I have what x is, I can take one of the two original equations and plug it in. So I get y equals 3 times 2, so y is equal to 6. I have what x equals 2, I have what y equals 6. Let's double check that that works for both equations. So I plug in for y equals x plus 4, I plug in 6. 6 is equal to 2 plus 4. It is a true statement. It works. The second one is y equals 3x, so I plug in 6 equals 3 times 2. It works. True statement. So I know my answers are right. Before I move on, I know that my answers are correct because I plug them back into the original. Let's look at another example. We're going to solve this by substitution, but only one of my two equations has a variable equal to everything else. That's perfectly fine. I've got that y is equal to x minus 7. So what I can do is I can substitute the y in the other equation for what the y equals to in the first equation. So I'm going to rewrite the second equation, 2x plus, and I'm going to substitute the y with x minus 7, and then finish writing that second equation, equals 8. Notice I still now have one equation, one variable I can solve. So I get 2x plus x minus 7 equals 8. These two combine to give me 3x minus 7 equals 8, and I add 7 and divide by 3. I get x equals 5. Now to get what y equals, I'm going to take one of the first two original equations, y equals x minus 7, I'm going to plug in 5, and I get y is equal to negative 2. It's fine to have a negative answer. I've got x equals 5, y equals negative 2. Now check yourself. Plug it back into the two originals. Y equals x minus 7 will be negative 2 equals 5 minus 7. Negative 2 equals negative 2. True statement. 2x plus y equals 8 will give you 2 times 5 plus negative 2 equals 8. 10 minus 2 equals 8. 8 equals 8. True statement. It works for both. So I know I have the right answer. And this is my answer, 5 and negative 2. Let's do another problem. Sometimes the system is written so that it's not quite apparent how you should solve the system. When you are looking at this and you're thinking in terms of substitution, look at the coefficients of your variables. Coefficients being the numbers before the variables. Here I've got a coefficient of 2 in front of the x. I've got a coefficient of 4 in front of that y. I've got a coefficient of a 1 in front of this x. And I've got a coefficient of a negative 3 in front of that y. You want to use substitution when you have a coefficient of 1. So the variable that has a coefficient of 1 is this x. You can see that right before it there's nothing there, so it's a coefficient of 1. So you want to solve for x because that variable has a coefficient of 1. So if I take this x minus 3y equals 7 and solve it for x, I need to add 3y to both sides. And I get x equals 7 plus 3y. Now that I solved it for x, I have that x is equal to 7 plus 3y. And where I have an x in the other equation, I can substitute that x with 7 plus 3y. So that top equation becomes 2 times, parentheses, what did I plug in for x? I plugged in 7 plus 3y. Always make sure when you plug in something for a variable, you need to put parentheses around it. So 7 plus 3y goes into parentheses plus 4y equals negative 6. So you see how I just wrote the first equation, but I substituted the x for what x was equal to in the other equation. Now that I have this, I've got one equation, one variable. I just need to simplify it. So I have parentheses here. I must distribute over the addition. I get 2 times 7, 14, plus 6y plus 4y equals negative 6. Add the two like terms. Subtract 14. And divide by 10. So I get y equals negative 2. Y is equal to negative 2. How do you get x? Well, what we do is we take one of our two original equations, and it can be this one because I just simplified that second equation, and I plug in negative 2 for y. So x is going to be equal to 7 plus 3 times negative 2. So I get 7 plus negative 6. X is equal to 1. I have what x is equal to. I have what y is equal to. The very last step is to check to make sure it works for both of our two original equations. So I'm plugging in negative 2 for y, and I'm plugging in 1 for x. So I get 2 minus 8 equals negative 6. It works. My second equation is x, so it would be 1 minus 3 times negative 2 equals 7. 1 plus 6 equals 7, 7 equals 7. It works for both equations, so I know that I have the correct solution, which is x equals 1 and y is equal to negative 2. That's the end of the movie on solving a system using